Hello everyone. Now we are going to see the topic about data structures. What is data structure? A data structure is a way of organizing and storing data in a computer so that it can be accessed and modified efficiently. The data structures are a fundamental concept in computer science and programming. It providing a means to manage large amounts of data efficiently for various computing tasks such as searching, sorting, and indexing. Why are data structures important? It is our first one is efficient data management. The efficient data management is a data structure enables organization and the storage of data, which in turn allows for efficient algorithms. Whether you are operating on a few items or million data structures like arrays, linked lists, trees, and hash tables can significantly improve our performance. What is improve our performance? The right data structure can drastically reduce the computational time required for operations like addition, deletion, and search. For instance, using an array to implement a stack is generally faster than using a linked list because of better cache locality. Also, data structures like heaps and balanced trees can be used to achieve operations with logarithmic or even constant time. The third one is the resource optimization. Data structures can help to optimize the usage of resources like memory and CPU cycles. For instance, it can be a memory efficient for storing a large number of things than a hash table. Then the next one is code reusability and abstraction. In data structures, it provides a level of abstraction that allows the algorithm to be reusable. For example, the algorithm like sort and search can be implemented independently of the underlying data structures, making it easier to understand and reuse the codes. Then the next one, improved problem solving. Understanding different data structures helps in choosing the right tool for the job, making it easier to solve complex problems. This is particularly important in areas like database designs, operating systems, and resource constrained applications like embedded systems also. Then data relationships. It is a complex data structures like trees and graphs are essential for representing hierarchical or interconnected data, such as organization charts, social networks, and web pages. Next one is enhancing algorithm efficiently. How to enhance the algorithm efficiently? It is a sophisticated algorithm, often require equally the data structures. For instance, graph algorithms like Dijistra's shortest path algorithm or various networks. In flow algorithm would be incredibly inefficient without appropriate data structures. Data structure is to represent the data in the graphs. Then the next use is the real world applications. Then many real world application systems rely on advanced data structures. For example, in the database need to manage and query large data efficiently. The search engine must index and serve pages at scale. The networking software must route packets of data through complex systems and so on. Then the scalability. As the volume of data grows, there is a growing need for scalable solutions. It is a good data structures like balanced trees and distributed hash tables can be the difference between a system scales gracefully and once the data cannot handle the load. And next one, the topic types of data structures. In the data structures can be broadly categorized into two types. First one is linear data structures, and second one is non-linear data structures. Then the linear data structures. First one is say the topic about the array. It is a fixed size contiguous allocation of elements, typically of the same type. The elements can be accessed directly by their index. Next one, the linked list. A linear collection of elements called nodes, each of which points to the next node in the sequence. And the types include singly linked list, then doubly linked list, and circular linked list. The next one is stack. A stack, a last in first out a linear data structure. The elements are added and removed from the same end. That is called the stack. And next one is queue. Queue is FIFO, that is first in first out linear data structure. The elements are added at the rear and removed from the front. Then the dynamic array or array list. Similarly to one array, but with dynamic resizing allows for efficient random access and appending the elements. Then the next one is DQ, that is the double-ended queue, allow insertion and deletion at both ends, making it a generalization of both stack and queue. Then the next one is priority queue. The elements are kept in sorted order, that is either maximum or minimum, other element using the heaps. Then the next type is the non-linear data structures. And the first one, trees. A hierarchical structure composed of nodes connected by edges. The types include binary trees, binary search trees, AVL trees, then B trees, then red-black trees, and so on. Then the heap, a special binary tree that maintains a specific order between parent and child nodes. The type include minimum heap and maximum heap. Then the graph, it consists of a set of nodes and a set of edges connecting the pair of nodes. The types include directed and undirected, weighted and unweighted graphs. Then the chain, a tree-like data structure that stores a dynamic set of strings and is particularly effective for searching through large dictionaries and phone books. Then the hash table or hash map, it stores the key value pair and uses hash function to index the keys, allows for quick data retrieval. Then the skip list, a data structure that allows for fast search within the ordered sequence of elements, effectively a randomized extension of a linked list. How are data structures used? The data structures are used in a wide array of applications for organizing and storing data in the computer in a way that enables efficient access of modification. In the software development, the array and list commonly used to store collection of elements that can be accessed by an index, such as sorting algorithm or simple data storage. In the linked list, often used in case that elements need to be inserted or removed frequently. Such in a memory management or implementing other data structures like stacks and queues. In the stack, widely used in algorithm, it is the process like depth first search, backtracking algorithm, and even in operators like undo functionality in text editors. And the queue, useful in breadth first search. It is BFS in scheduling algorithm and to maintain a first come first serve order in a line of tasks that like printing. Then the hash table, it employed in database for quick data retrieval in caching mechanisms and to maintain the set of elements for quick membership test. In the trees, it is used in hierarchical data storage like file system. The file, the directories containing files which may contain directories themselves. The specific tree structures like balanced trees and AVL trees are used in database for efficient data access. In the networking, the graph used in representing and processing the network of algorithms, and in social networks to represent connection between individuals. In the queue, employed in packet switching and scheduled tasks. Next, the database. In the database, the B trees and hash indexes. Uses of enabling quick data access, searching and sorting operations. In the linked list also, for storing records in a certain type of database, then the particularly in a memory database. The uses of artificial intelligence and machine learning. In the tree section, the decision trees are one of the basic algorithms in machine learning. In the graph, it is used in neural network and state measures. In the array and matrix for data sets, the future vectors, etc. Next one, the uses in the game development. In the array format, we store the data in game boards, in a chessboard or tic-tac-toe in the array format. In the graph, for representing game states at a possible movement in a game. In the stack, for undo functionalities and depth first search in pathfinding algorithm. Next, the uses in operating system. How the data structure is used in operating system. In the queue format for scheduling the task. Then the stack format for process isolation and function call handling. In the tree structure, the directory structures and the permission of hierarchies to be enabled. The uses of web browser in the data structure. In the stack format for maintaining the back and forward navigation of stacks. Then the tree format, the document object model is a web browser is essentially a tree. The next topic is the characteristics of data structures. The data structures have certain characteristics that define their agility and efficiency. Understanding these characteristics can help in choosing the right data structures for a given task. Here are some important features and characteristics of data structures. The first one is time complexity. The time complexity, insertion time, the time taken to add an element in your data structure. The deletion time, the time taken to remove an element from your data structure. Then the accessing time, the time taken to find an element or retrieve it. In the search time, the time taken to find an element within the data structure. Then the next one is space complexity. In the memory usage, the amount of memory consumed by the data structure. Then the data organization. It is a linear structure. The data is organized sequentially. For example, arrays or linked list. Anyway, utilize this type. Then the hierarchical, the data is organized in a tree structure. For example, the binary tree, heap tree, etc. In the graph-based data is organized in a network, that is the graph structure. Then we want to know the structure in the tabular format. The data is organized in hash tables. Then the data access model. In the direct access, immediate access to individual elements from the arrays. In the sequential access, the elements are accessed sequentially in the linked list. Then the random access. The elements can be accessed in any order but not immediately. For example, the binary search tree or the hash table. Then the next one is mutability. Mutability is, there are two types of mutability. One is static and another one is dynamic. The static, the structure is fixed in the size. For example, the arrays. Then the dynamic mutability, the structure can grow or shrink. For example, trees, linked list, graphs, etc. Then the functionality, it is the three types of functionalities in the data structures, that is the ordering, uniqueness and indexing. In the ordering, whether the data structures kept in elements in a sorted order. In the uniqueness, whether duplicated data are allowed. In the indexing, whether the elements can be accessed using an index or a key. Then the usability, ease of implementation. In the data structure, some data structures are straightforward and simple to implement, while other like balanced trees or hash tables can be quite complex. Then the flexibility, how versatile the data structures for a variety of tasks. Then the next topic is abstract data types, that is ADT. The ADT are the foundational concept in computer science and software engineering. It is serving a blueprint for creating more complex data structures. They define the nature and behavior of a data structure, but not its implementation. In other words, ADT provide a way to describe what a data structure does, but not how it does it. The components of data structure sense of first one the data, second one is operation. A data, the values that will be stored by the data structure is called a data. The set of functions of methods that can be applied to the data is called a operation. In the formal definition of abstract data type is, it defines the mathematical notation of specific properties and operation. For example, the list ADT can be defined as a tuple L equal to D comma 0. In the example, the tuple L equal to D comma 0, D is a finite order set of elements. Then O is a set of operations that's like insertion, deletion, then find, etc. Then the characteristics of ADTs are encapsulation. Encapsulation data and operations that manipulate the data, exposing only the essential features to the outside world. In the abstraction, the ADT provides a high level of abstraction, it allowing the programmer to focus on what operations are needed rather than how to implement them. Then the information hiding. The actual internet working on ADT are hidden from the user. User interact with the ADT through a well-defined interface. Then the reusability. ADT can be implemented in multiple ways, which make it reusable. You can switch from one implementation to another without affecting the rest of the code. And the integrity, ADT ensures that the operations performed are valid, then thereby maintaining the integrity of the data. The common abstract data types are, first one, the list ADT, stack ADT, queue ADT and tree ADT. First we know list ADT. Define the operation for a sequential collection of elements. That the operations like insert, delete, find, size, etc. Then the second one is stack ADT. That is last in first node behavior. That is LIFO behavior. In the operation push, pop, peak is empty. These are the operations applied in stack ADT. Then the next is QADT. That is a FIFO behavior. That is fast in first node behavior. In the QADT, the operations like NQ, DQ, front is empty. These operations are included in QADT. Then the tree ADT, it is the hierarchical data structures. What are the operations are we include in the tree ADT? That is insert, delete, find, traverse, etc. In the graph ADT, the set of nodes and edges. Then the operations like add vertex, add edge, remove vertex, remove edge, find adjacent nodes in the graph, etc. Then we see the topic about linked list. What is a linked list? The linked list is a data structure used to organize a sequence of elements where each element contains a reference or link to the next element in the sequence. Unlike arrays, the linked lists are not stored in contiguous memory locations, which makes them dynamic and easily expandable. A simple form of linked list is known as single linked list. It includes the node have two fields. The first node, the field is data, second one is the address field. The data field stored the actual value, what data to be stored. And the address field, which is the reference to the next node in the linked list. In the diagram, there are the two portions are in the diagram, that is data and the address. The data stores the value, the address denotes the next portion of the node. It stores actual value. Then the doubly linked list, it is a single linked list. It is a doubly linked list. They have two reference in the each node. In this diagram, the data, it shows the value. In the address, shows the previous node of the address and the next node of the address. The linked list ADTs have the following steps in the creation, insertion at the beginning, insertion at the end, insertion at the position, deletion from the beginning, deletion from the end, deletion at the position, traversal, searching. These are the features in the traversing in the linked list. Advantages of linked list over arrays. The linked list and arrays are both fundamental data structures, but they have distinct advantages and disadvantages. Here are some advantages. First one is dynamic size. In the linked list, the size of the linked list is dynamic. It means allocate and deallocate memory on the fly, and it can grow or shrink as required. In the array, it is the static data structure. It means it's a fixed at the line of creation. Dynamic arrays exist but require resizing and copying to be expanded. Second one is ease of insertion and deletion. So in the linked list, insertion and deletion in any position, we can remove or insert the data before the way wish to delete it. In the array format, it is same as inserting or deleting elements required shifting the elements making that is the operation worst case. Next, no wasted memory. Linked list and array, no wasted memory. It is the node is allocated only when needed, avoiding wasted memory. Then the better cache locality for non-sequential access. If you are inserting and deleting elements of a linked list, it maintains better cache locality. For those specific operations, fewer elements need to be removed around. In the array format, insertion or deletion is arbitrary points record data, shifting, resulting in a poorer cache locality for those type of operations. The next one is flexibility. The variations like doubly linked list or single linked list is more flexible for specific user cases in linked list format. The structure and don't offer the built-in variations like arrays. Simplicity of memory allocation. Memory is allocated for each new element during runtime, typically from the heap, which is straightforward operation in a linked list. In the array format, dynamic arrays are required resizing, which involves allocating new memory and copying old elements for more complex process than in linked list. Then the complexity of element data type. When an element needs to be added or removed, only the references in the adjacent nodes need to be updated. Then, depending on the operation, shifting elements may be required, which can be computationally expensive. The limitation of linked list. The first one is random access. One major drawback that is the linked list do not provide constant time access to individual elements. To access an element, you have to start the head and follow the reference until you get to the desired element. And the external memory also available in linked list. But the limitation, each node in a linked list to store at least one reference to another node, requiring extra memory overhead. In the cache locality, it is a poor cache locality can sometimes make a linked list perform poorly compared to arrays for certain type of tasks. Next, the single linked list. In a single linked list, it is a type of data structure that is used to store a collection of elements. Is called a node. Each node contains a data item, and a reference to the next node in the sequence is called a address. The list is highly single linked list because each cache point of the node only to the next node in a sequence, not the preceding one. The first node is referred to as the head, and the last node which has a null reference of the value. It is the structure of a node, and the node consists of data and address. The data is the actual value, address is the next node. Then in the diagram, the data and head, the data stores the value, that is 601, it is the address of the 601, then move to 701, then move to null value. Basic operations of a singly linked list. Here are the basic operations that can be performed in a linked list. First one is insertion at the beginning. How to insert the node in the beginning. In the diagram represents the node in the beginning, that is the new node 5 is inserted in the position. This is the algorithm is followed. In the algorithm, allocate memory for a new node. Then assign the data to the new node. Make the next to the new node the point to the current head node. Update the head node to the new node. These are the algorithm used in the insertion at the beginning. Then the next, insertion at the end. In this diagram, insertion at the end, the new node 5 is inserted to the last in the node. In the algorithm is followed. The first step, allocate memory for the new node. Then assign the data to the new node and make its next is null. If the list is empty, make the new node to the head. Otherwise, traverse the last node and update its next node to the new node. Then the third one, insert the data in the position. In this diagram, what is the position you go to insert in the node? The 5 is inserted in between the node is 20 and 30. So using the algorithm, we follow the algorithm. In the algorithm, allocate memory for the new node. First you allocate the memory for the new node. Second, assign the data to the new node and make its next to null. If the list is empty or if the position is 1, make the new node to the head. Otherwise, it traverses the given position node. The position node is next is update to the new node and the new node is update to the position node. Then the next one, deletion from the beginning. How to delete the node in the beginning? So in this diagram, we delete the node in the beginning. 501 is head, then temp is 501. Then as it is follows the temp 601. These are the sources of the data and the address. In this algorithm, check if the list is empty. First you check the list is empty or not. If so, return, update the head to the point to the second node in the list. Free the memory space of the first node. Then the next step, deletion from the end. Deletion from the end in this diagram, how to delete the node in the front. And then the 601 of the address is deleted in the from the beginning. The procedure is followed. The algorithm is first step in the algorithm. If the node is empty or not, first you check the node is empty or not. If so, return. Traverse the list to find and the last node and the first previous of the node. Set the next pointer to the second to the last node to null. Free the memory space of the last node. So the position in the particular node is deleted. The next one, deleted at the position. How to delete the position of the node? In this algorithm, we followed. Then the first step of the algorithm, check if the list is empty or not. If the position is invalid, suppose the position is invalid, So return the particular area. It reverses the list to find the node of the desired position and is the previous node. Update the next pointer to the previous node to the hidden node at the desired position. Free of the memory of the node at the desired position. Then traversal. How to traverse the linked list? Start from the heap node, head node, visit the each node and perform the desired action. Move to the next node. It continue until reaching the node with the next pointer to null. Then the searching algorithm is start the head node first. Check the data at each node. If a node you will given the data is found, it return to you. If no such a node is found, by the time at the end of the list is reached, it returns null. This is the algorithm used in searching. Then the last topic is the drawback of single linked list. It is no random access. It is a direct access to individual elements is not possible. Once it has to be iterated from the head node to access the particular node only. It is the first drawback. The second drawback is forward navigation only. You can only traverse in one direction from the head of the linked list of the end single link.